Good day, students. Today our topic under signals and systems will be periodic and aperiodic continuous time signals. So what is called as a periodic signal? We can take here this signal, sine wave signal here for illustration. Just observe the pattern of this particular signal, right? You can see that there is a repetition factor involved in this signal. If you closely observe, if I start from 0 till 2 pi, this same signal repeats at 2 pi to 4 pi, 4 pi to 6 pi and so on. Similarly, the same signal repeats from minus 2 pi to 0 and then again from minus 2 pi to 4 pi up to minus infinity. Hence, every point of the signal gets repeated with a fundamental time period. Here, the fundamental time period can be taken as this one. So, I can see that this is going to be my fundamental time period, which is nothing but the upper end 2 pi minus the lower end 0, which is the fundamental time period. How much ever I shift this signal over the fundamental time period, either as a delay or advance, the signal remains the same. So, this type of signal is called as a periodic signal. So, a continuous time signal which repeats itself after a fundamental period of time is called as a periodic signal. What is a condition for periodic signal? It should satisfy the condition x of t plus or minus mt is equal to x of t. The significance is that the plus or minus indicates that the signal can either be a time delay or it can be a time advance. M is going to be an integer. For example, if you are going to take the value of m is equal to 1, and we know very well here in this example that I have taken, your fundamental period is 2 pi, right? So, if I find x of t minus 2 pi, right, x of t minus 2 pi where the value of m is going to be equal to 1. So, this x of t minus 2 pi is nothing but time delayed version of the signal by 2 pi. You try to plot x of t minus 2 pi for this, you will be again getting the same signal. So, the signal even after getting shifted remains the same. Whether it is going to be m equal to 1, m equal to 2 or any integer, the signal is going to be same. So, such type of signals are called as periodic signals, right? So, t is the smallest value for which the signal repeats itself. So, the value of t, you cannot take t as 0 to 4 pi, right? You can observe that even from 0 to 4 pi, the signal is repeated, right? But anyhow, we should take the smallest value of t, which with which the signal repeats itself. So, you again observe it carefully, you will be seeing that the smallest value of t for which the signal repeats is going to be equal to t equal to 2 pi, right? So, it is very important that any signal which satisfies periodic condition should satisfy this condition. Then, a periodic signal, aperiodic signal or not an aperiodic signal is one which does not satisfy this condition, x of t plus or minus mt is not equal to x of t. So, when you shift the signal as a delay or advance and the resultant signal that you get, if it is not equal to the original signal, then that type of signal is called as an aperiodic signal. Let us take some examples, right? Just you try to take a moment, you can pause your video and take a moment, analyze whether this signal is going to be a periodic signal or an aperiodic signal. You can pause your video and analyze, right? Okay, hope you have analyzed. So, you can see here that there is a repetition rate for this signal. It extends here the signal repeat itself from t equal to minus infinity to plus infinity. See, I have not shown here entire thing. It is obvious that it extends from minus infinity to plus infinity. So, what is the fundamental period with which it repeats? You can see that the smallest fundamental period is t equal to 1 second. Hence, the fundamental period is t equal to 1 second. So, if you try to shift the signal, that is, I told that m can be any integer, it can be either a time advance version or a time delay version. So, x of t plus 1, x of t plus 2, x of t plus 3 up to x of t plus infinity are time advanced versions. You do any time advanced version, you will be getting the same resultant signal. Similarly, when you delay the signal up to infinity also, you will be getting the same signal. So this signal is said to be a periodic signal. So the initial examples that I am giving you is just to give a intuition of how a periodic and aperiodic signal will look like, right? Moving on to the next example, right? So here I have given this example. I have started here from 0. Observe that there is no signal beyond this 0. So and here if I have given like this, it means that it continues up to infinity, right? So just take a moment, pause your video and then analyze whether the signal is periodic or aperiodic. Okay students, I think you would have inferred. So here you can very well observe that the signal does not repeat itself from minus infinity to infinity. So where does that discontinuity occur, right? You can see that below 0 or before 0, there is no signal that is being present. Maybe the signal is repeating from after 0 till infinity, but before 0, there is no signal. Even if there is discontinuity even at a single point also, the signal will be said to be an aperiodic signal. So here you can see that x of minus t is 0. There is no fundamental period. So what is x of minus t equal to 0? I am just trying to tell that the negative portion of the signal x of t is 0. There is no fundamental period and hence the signal is said to be aperiodic signal. Right. One more example. Just take an example, look into it, give a deep insight. Okay, fine. I think you would have done. So proceeding on, you can see very well from the figure, even though it is sine wave, you can see that there is absolute discontinuity at this point, right? So from here to here, the signal is 0 and after that again it continues to do till minus infinity and till plus infinity. So even though the signal is going to be continuous at all other points, even though there is a small discontinuity at one point, the signal is said to be an aperiodic signal. So x of is discontinuous at point t equal to pi. Hence the signal is said to be aperiodic signal. Right? Till now we have seen just by looking into a signal, you can tell whether it's a periodic or aperiodic signal, but it is always not necessary that your signal will be always represented visually. So whenever you are given an equation based signals, you need to go into an analytical approach to find the periodicity of the continuous time signals. So let us start with certain examples, right? So here, determine periodicity and specify the fundamental period of the signal x of t equal to j e power j 10t, right? So first you have to look into what type of signal it is, right? So because only when you look into what type of signal it is, you can follow the specified procedure and find out the periodicity. So the first step in checking for periodicity in analytical approaches, you have to find what is the type of this signal. So you can observe that this signal is nothing but a complex exponential signal which you have studied in the types of signals itself, right? So what is the general form? Complex exponential signal x of t is of the general form c e power j omega naught into t, right? So c is going to be a number which can either be complex or real, right? Omega naught is nothing but the fundamental frequency, right? So here c equal to j, and now you compare this equation with the standard equation with the equation or the signal given in the problem. So when you compare these two, it is very much evident that the value of c is equal to j, and you compare the value of omega naught equal to 10, right? Now what you have to do is, you have to check, you have to find the time period, fundamental time period. So we know very well that omega naught is equal to 2 pi into f naught, which is nothing but 2 pi divided by t naught. From this, the value of, you substitute the value of omega naught, you will be getting the value of t naught is equal to pi by 5. I hope it is clear. So you have found out the fundamental period in the signal is pi by 5, right? But you have to ensure whether the signal repeats every time for this fundamental period. That is, you have to check whether the signal satisfies this condition, x of t plus t naught. You should find x of t plus t naught, or you can also find x of t minus t naught, right? Whatever may be. After finding this, you have to check whether it is equal to x of t. So, x of t plus t naught is equal to, in my original signal of x of t, I am just substituting j e power j 10. In the place of t, we are going to replace it by t plus t naught. So, the resultant will be j e power j into, it is actually here t. So, t plus the value of t naught is pi by 5. So, here note down, it is not j, it is going to be t. So, t plus pi by 5. You have to simplify. So, how can you simplify further? You can see that this can be written as j e power j 10t, right? So, keep in mind this is t. So, into e power j, 10 into pi by 5, you will be getting e power j 2 pi. You know very well that Euler's formula. What is Euler's formula? E power j theta is equal to cos theta plus j sin theta. So, you can see that here e power j 2 pi can be written as cos 2 pi plus j sin 2 pi, which is equal to 1. So, it is a well known identity that e power j 2 pi equal to 1. So, here you can replace this a power j 2 pi equal to 1, right. So, what you will be getting here, when you replace it as 1, you will be getting j e power j 10t, which is nothing but x of t. So, we have very conveniently proved that x of t plus t naught is equal to x of t. The meaning is, this complex exponential signal is said to be a periodic signal with a fundamental time period t naught equal to pi by 5, right. I hope it is clear. So, again, just to check the condition for periodicity, the steps that you have to follow is, first you have to identify what is the type of standard form representation of the signal that is being given, right. Secondly, from that you should find the fundamental time period t naught. Then you have to check whether x of t plus t naught or x of t minus t naught, whether it evaluates to x of t. If it evaluates to x of t, the signal is said to be a periodic signal. So, here one important inference from here is, you take any complex exponential signal, you will try and find out that complex exponential signals are always periodic. So, this will be a hint to you to just remember. Second, moving on to the next question, determine the periodicity of the signal x of t equal to 3 cos 4t plus pi by 3. Please do take some amount of time by pausing your video and just try to analyze what this type of signal is, right. So, after analyzing this, you can see that the given signal x of t, first you have to fix it into a standard form. So, what is the standard form of the signal? It is nothing but a cosine signal, x of t equal to a cos omega naught t plus 5, right. So, now you compare this standard form signal with the signal which is given over here and find out what is the fundamental period t naught. So, the angular frequency is omega naught. So, omega naught is equal to 4. So, omega naught equal to 4. Proceeding on, omega naught you can write it as 2 pi f naught. F naught can be written as 2 pi by t naught, which is equal to 4, and then you can obviously find t naught equal to pi by 2. So, we are finding that fundamental period is pi by 2. Next, we have to check whether the signal repeats for this fundamental time period. So, what you should do? You have to check the condition x of t plus t naught. You have to find whether x of t plus t naught is equal to x of t. So, what you do? X of t plus t naught is equal to, in your original signal, you take this original signal, instead of t you are putting it as t plus t naught. So, wherever you have t, replace it as t plus t naught. So, x of t plus, in the place of t naught I am going to put it as pi by 2. So, is equal to 3 cos 4. In the place of t you are going to replace it as t plus pi by 2 plus pi by 3. Please keep in mind that you should simplify in a manner that you should try to get whether, you should just check whether it is going to be equal to x of t. So, what we are doing is, the next step is, you are simplifying 3 cos 4t plus 2 pi plus pi by 3, right. So, the hint you can observe here, 4t plus pi by 3 plus 2 pi, which is nothing but 3 cos 4t plus pi by 3. You know very well, right, cos of cos of theta plus cos of any value or any angle theta plus 2 pi will be equal to what? It will be equal to cos theta, a very fundamental trigonometric identity, right? So you can see that here in the place of theta we have what? 40 plus pi by 3, right? You have 40 plus pi by 3 in the place of theta. So that theta plus 2 pi is nothing but 3 cos 40 plus pi by 3, which is nothing but my actual signal x of t. So it is very much evident that x of t plus t naught is equal to x of t. Hence a signal is periodic with the fundamental period of t naught is equal to pi by 2. One more inference here is you try to plot out any type of fundamental sine or cosine signals. So sine or cosine signals which are of this form, right? It should be of this linear form, right? So this type of sine and cosine signals are said to be periodic signals. Moving on to one more example, check for periodicity of the signal. X of t equal to e power minus 1 plus j into t. Pause the video and take a moment to analyze what this type of signal is. Okay, if you have analyzed this properly, this signal is not only a complex exponential signal, because if you have just e power minus jt alone, you can tell it's just a complex exponential signal. But here it has this minus 1 factor also. So it's a combination of both real exponential signal as well as a complex exponential signals. So you need to bring it into a standard form. So the signal x of t is not in the standard form. So you have to convert it into standard form. So how can that be done? X of t equal to e power minus 1 plus jt. Just simplify e power minus t into e power jt, right? Which is equivalent to nothing but e power j omega naught t. This e power minus t is nothing but a real exponential signal, and this is going to be a complex exponential signal. So just compare this complex exponential with this e power j omega naught t, right? So when you compare, you will be getting omega naught value is equal to what? 1. Just compare, you have to compare this part alone, right? Because this one alone is a complex exponential signal, right? It's a complex exponential signal. So you cannot compare this real, it's just a separate part. So when you take, you can see that omega naught value is equal to 1. So find out the value of t naught as usual. So t naught you will evaluate to 2 pi. Obviously next you have to check whether the signal is periodic. To do that, you go for x of t plus t naught. So in the original equation, either you can take this one or you can even take this one, right? In this equation, in the place of t, you have to replace it by t plus t naught. Here t is 2 pi. So x of t plus 2 pi equal to e power minus 1 plus j into t. So here in the place of t, you have to replace it as t plus 2 pi, right? So it has to be actually replaced as t plus 2 pi, which is missing over here. So it should be actually, I'll just point it out over here. It should be actually t plus 2 pi. That is, in the place of t, you have to replace it as t plus 2 pi, right? So now you simplify this, you will be getting e power minus t and then e power minus 2 pi and then e power jt and e power j2 pi. Look into what all possibilities can be simplified. It's very evident that e power j2 pi is nothing but 1 as per Euler's formula. So the remaining what you are getting is e power minus t, e power minus 2 pi, which is some constant. It's not equal to 1. It is some real number into e power jt. You try to bring it into this form. You can see that e power minus t and e power jt you are combining and bring it in as minus 1 plus j into t, right? Which is your original signal x of t. But however, it is getting still multiplied by e power minus 2 pi. So you can see that x of t plus t naught is equal to x of t signal, which is multiplied by e power minus 2 pi. So x of t plus t naught is not equal to x of t. Therefore, the signal is said to be an aperiodic signal. So this type of signal, which is a combination of real exponential and complex exponential signal, will evaluate to an aperiodic signal. If the very important takeaway from this particular problem is, if the given problem is not in a standard form, it has to be converted to standard form to check for periodicity. So you can see, right, it was not of the standard form. So I need to find omega naught. So you have to convert your omega naught into 2 pi and convert it. Hence this signal is an aperiodic signal. Proceeding on to the next problem. Check for periodicity of the signal x of t equal to 2 cos 10t plus 1 minus sin 4t minus 1. Take a moment and just look at. So x of t equal to cos 10t plus 1 minus sin 4t minus 1. The different thing in this problem is, earlier you have seen problems where there were just one type of signal, but here you can see that there are two signals, or the given signal x of t is an addition of more than one signal, right? So in this case, how will you proceed for the solution? So the first thing is, you have to find out what are the two, split both the signals. So you can see here that x of t equal to x1 of t plus x2 of t, where x1 of t is nothing but 2 cos 10t plus 1 and x2 of t equal to sin 4t minus 1. As usual, in the next step, you have to look into whether the signal is of the standard form. So observing, you can see that x1 of t is of the standard form cos omega 1 t plus phi, and x2 of t is of the standard form a sin omega 2 t plus phi, right? So our inference here main is to find out what is omega 1 and omega 2. So you try to compare this one, you can see that you can try to compare this signal. You can find that this is 10 and here it is omega 1, right? Similarly, here it is 4, which can be compared here with omega 2, right? So when you compare, you can find out that the value of omega 1 is equal to 10, right? From this you can find out what is the value of t1, right? Then proceeding on, you can find out omega 2 equal to 4. So you can find out t2 is equal to pi by 2. So after finding the individual fundamental periods of t1 by t2, a shortcut method to check for periodicity is, you need to find out the ratio of t1 by t2. So you have to find what is t1 by t2. So the point is, if the ratio of t1 by t2 is a ratio of rational integers, then the signal is said to be periodic signals. If t1 by t2 is not a rational, then the signal is said to be aperiodic signal. So here t1 by t2 you find, you will be getting pi by 5 divided by pi by 2 is equal to 2 by 5. Don't simplify this. You should have a number in the numerator and then a number in the denominator. These two numbers, if they are a ratio of integers, the signal is said to be periodic. So we can tell that since the ratio is the t1 by t2 is a ratio of integer, this given signal is said to be periodic, right? But however, we have to find what is the fundamental period of this combined signal x of t. We have found out the fundamental periods of two individual signals, but we need to find what is the fundamental period of this combined signal x of t. So how do you find that? So we find, to find out the fundamental period t naught, you should take the LCM of t1 comma t2, right? So there are two methods in which you can find out the LCM. So just one thing I have covered here, the other one we can see in the introduction class. So you can find t1 by t2 is 2 by 5. So t naught is nothing but, you just cross multiply this 5t1 which is equal to 2t2. You substitute the value of t1 that we have found earlier, pi by 5, or you substitute the value of t2 which is pi by 2. When you do both these cases, you will be getting t naught equal to pi. So you can tell that already we found out that the signal is periodic. Now we have found out that the total fundamental period is equal to T naught equal to pi, right? You can also still extend further by verifying our fundamental condition if x of t plus t naught is equal to x of t. So how that is being done? In my original equation, wherever I have t, right, it should be replaced by t plus 2 pi. So that is what we are doing here. X of t plus pi is equal to 2 cos 10t plus pi plus 1 minus sin 4t plus pi minus 1. Your objective is you should try to bring it to the form of x of t. In that manner only you have to do the simplification. So 10t plus 1 plus 10 pi and minus sin 4t minus 1 plus 4 pi. We know that in our signal we have this term 10t plus 1 4t minus 1. So we should try to preserve that form. So keeping that, how can we simplify? You can see that cos of theta plus 10 pi. 10 pi is nothing but 2k pi, right? It's a multiple of 2 pi. So cos of theta plus 2k pi is cos theta, and similarly here sin of theta. Here theta is nothing but 4t minus 1 plus 4 pi is equal to sin theta. So obviously this will evaluate to 2 cos 10t plus 1 minus sin 4t minus 1, which is equal to x of t. Therefore x of t plus capital T is equal to x of t. So I hope you are clear with this procedure. Just to summarize, what is the procedure for this type of problem where you have an addition of more than one signal? In that case, the first step is you have to identify the signals individually, that is x1 of t and x2 of t. Then you have to check as usual whether they are in standard form. If they are not in standard form, you have to convert it. If they are in non-standard form, you have to convert it into standard form. After converting it into standard form, you have to find out omega 1, omega 2. From that you need to find T1 and T2. After finding T1 and T2, you should find the ratio of T1 by T2. If it's a ratio of integer, the signal is periodic, and if it's not rational, then it is said to be aperiodic. After finding this, you need to find the total fundamental period T0. So T0 is equal to LCM of T1 by T2. From that you can find out the total fundamental period T0. The next step of verifying x of t plus T0 is equal to x of t is optional for problems which have addition of more than one signals. Based on whatever you have learned, please apply these practice problems and try to do. Look into the hint also given. Thank you, students.